Hi everyone. So we'll continue with pulleys or the Atwood machine. Now, whenever we have pulleys, we are normally going to have more than one mass. That makes the problem a little bit harder, but it's not that bad, I promise. The key is we consider each mass as independent from each other, meaning we'll draw a free body diagram for each of the masses. Okay, let's work in this example. It says, provided that mass 1 is greater than mass 2, find an equation which describes the acceleration of the entire system. Assume the pulley is frictionless and that the mass of the cable is negligible. Don't forget, every time we have the word assume in physics problems, it's a good thing. So, better said, because if we don't assume that the pulley is frictionless and we don't neglect the mass of the cables, this problem becomes a monster, but we don't have to do that, okay? So now let's get started. As I said, the key is drawing a free body diagram for each of the masses. Even before I start doing that, notice that because mass 1 is larger than mass 2, we're going to have motion. There's going to be an acceleration, right? So the motion will follow this direction, and I'm going to label this as positive, just because that's the direction of motion. So down is positive for this example. Mass 2 will be moving upwards, therefore mass 2 will experience an acceleration which is negative. That's very important for us to know, okay? So now let's draw our vectors. So we have the weight of mass 1. There you go. We'll label m1 times acceleration due to gravity for the weight of mass 1. And then we'll draw the tension. Now I'm going to draw this slightly smaller than the weight of mass 1 because we have a motion, therefore our system has to be unbalanced. So this is slightly smaller. We'll call this tension. And then that's it. We have no other forces acting on mass 1. Now let's go for mass 2. Center of mass. We have the weight of mass 2 pulling down. There you go. We'll label as m2 times acceleration due to gravity. Since it's the same cable, these two tensions are going to be the same. So I can just copy this vector, place it over here against the weight of mass 2, and we'll label this as tension T. There we go, we're done. Now something which I'm going to do this time just to make it easier when we sum the forces is let's add signs for the forces. Let's decide whether they're positive or negative. If we said that downwards is negative because that's the direction of motion, then the weight of mass 1 is positive, right? Because it's moving downwards. Now tension is acting against the weight of the mass 1, therefore this is negative. However, for mass 2, it's a bit different because the tension on mass 2 is pulling it upwards, but is with the motion, with the overall motion of the system, right? Counterclockwise. Therefore, tension is positive for this one, and the weight of mass 2 is kind of slowing down mass 1, therefore is against the motion, so we label it as negative. You'll see why this is going to be very helpful. Now let's sum the forces. So we have that the summation of the forces acting on mass 1 will be equal to mass 1 times an acceleration because there's motion, right? And that'll be m1 times acceleration due to gravity minus the tension. This is where the plus or minus signs are going to be very helpful. Now let's do the same for the forces acting on mass 2. That'll be m2 times an acceleration, which will be equal to tension minus m2 times acceleration due to gravity. Now we know that the tensions are the same. We know the acceleration due to gravity. We don't know m1 or m2, and we don't know the acceleration. So we have a system of two equations with two unknowns, so we can solve it with algebra. As usual, we're going to take this part and rewrite it over here. So we have m1, let me redo that, m1 times acceleration is equal to m1g minus t for tension. Now we have m2 times acceleration is equal to, tension minus m2 times acceleration due to gravity. One way we can solve this system of equations is by adding them together. So let's do that. That'll be m1 times acceleration plus m2 times acceleration is equal to m1 times acceleration due to gravity plus tension minus tension minus mass 2 times acceleration due to gravity. Notice how tension and tension cancel each other out because they have opposite signs. Then we'll simplify. We have m1 times acceleration plus m2 times acceleration is equal to m1 times acceleration due to gravity minus m2 times acceleration due to gravity. We're trying to find an expression or an equation which will give us acceleration. And we can factor out acceleration from this side, and we can factor out gravity or acceleration due to gravity from the right side. Okay? So when we do that, we'll have acceleration times m1 plus m2 is equal to acceleration due to gravity times m1 minus m2. Right? Because if we distribute, it'll be a times n1, a times m2, same thing for the right side. Now to solve for a, we can simply divide by this expression over here, m1 plus m2 on both sides. This will cancel, and our equation which describes acceleration will be acceleration due to gravity times m1 minus m2 divided by m1 plus m2. And that is the answer. Not that hard. The key is draw a free body diagram for each of the masses, treat them as independent from each other, define direction of motion, make sure you stick to it, don't change signs, otherwise our whole process will be incorrect. And that's it for the first example on pulleys.